Okay, welcome to Success Phase 101 class. Um, Today is 15th of February, 2025. And currently, in continuation of our classes that have been going on so far, we're looking at dynamics today, linear dynamics today. And this is chapter 4 of your Phase 101. Dynamics, so far we have done chapter 1, 2, and 3. If you're following this online class, you must have had chapter 1, 2, and 3 already. This is chapter 4, dynamics, and we're about kicking off immediately. So class, let's write down dynamics. Is a study of objects in motion Dynamics is a study of objects in motion and the forces causing the motion. Dynamics is the study of objects in motion and the forces causing such motion. Dynamics is the study of motion and the forces causing such motion. Class, we're just coming from a chapter called Kinematics. In kinematics, we study motion, but we do not reference the forces that leads to motion in kinematics. Chapter 2, we looked at kinematics, and we talked about motion, but we do not reference the forces causing the motion. But in dynamics, we don't just talk about motion, we reference the forces causing the motion. Class, it's a well-known fact that for a body to move, a force needs to be applied. For a body to undergo motion, a force needs to be what? Applied. So in dynamics, we're studying those forces that are applied for the body to move. Now, class, in order to understand Newton's laws of to understand dynamics, we have Newton's 3 laws of motion. Newton's laws of motion helps us to understand the forces causing motion. Newton's law of motion. We have 3 laws. We have the first law, also called the law of inertia. We have the second law, also called the law of momentum. And we have the third law. This is the law of forces. So we have 3 Newton's laws of motion that helps us to understand why an object is moving. We have 3 Newton's laws of motion that helps us to understand why an object is what? Moving. Newton's first law, called law of inertia. Newton's second law, called law of momentum. Newton's third law, called law of forces. Now, class, we'll start with the first law, which is the law of inertia. Let's start with Newton's first law of motion. States that Newton's first law, the first law, states that a body at rest will remain at rest. States that a body at rest will remain at rest. States that a body at rest will remain at rest. And a body in motion with constant velocity and a body in motion with constant velocity will remain in motion. Will remain in motion with constant velocity in a straight line, with constant velocity in a straight line will remain in motion with constant velocity in a straight line unless it is compelled to change that state. Unless it is compelled to change that state by forces acting on it. Unless it is compelled to change that state by forces acting on it. Unless it is compelled to change that state by forces acting on it. By forces acting on it. Unless it is compelled to change that state by forces acting on it. Unless it is compelled to change that state by forces acting on it. Class, this is the first law of motion. And as we said, it's also known as the law of inertia. As we said, it's also known as the law of what? Inertia. Now, class, we need to define inertia then. What is inertia of a body? Class, as simple as this word inertia, it was asked in your past question. If you go to your past question, you see where they asked the tendency. Let's define inertia. Inertia is the tendency of a body. Tendency of a body to remain in its state of rest. In its state of rest. Inertia is tendency of a body to remain in its state of rest or uniform motion or uniform inertia, tendency of a body to remain in a state of rest or uniform motion. Tendency of a body to remain in its state of rest or uniform motion. Class, what keeps a body at rest before an external force is applied to it is inertia. Why have that body not moved? Why do we say that a body will remain at rest for thousands of years, for as long as to take, if no force is applied on that body to still be at that same place? Is the inertia of the body. Class, we can define inertia as the tendency of a body to remain in a state of rest or uniform motion. Class, it's not just state of rest that is inertia. A body will also continue in uniform motion. What is uniform motion? Uniform motion is the motion of a body with constant velocity. Constant what? Class, when a body does not change its speed, class, is said to be undergoing uniform motion. What we're trying to say is that a body will continue at that same speed except an external force comes to distort it or stop it from continuing at that same speed. So Newton's law of motion is in two sections. It doesn't just apply for a body at rest. It also applies for a body in uniform motion. When a body is undergoing uniform motion with constant velocity, that means you're moving at that same pace. Class, it is known that the body will continue at that same pace if there is no disturbance whatsoever. It will continue like that in a straight line, in a straight, except an external force comes towards, move it from that uniform motion. So a body what keeps a body to remain at rest, or what makes a body to retain its uniform motion is the inertia. We can also define inertia. Who is the past question here? This is the way the past question put it. Who is the past exam question here? This is the way the past question put it. Quickly open to physics there. Quickly open to physics. Open to physics. Someone fast open to physics. Part of the past exam questions. Open to physics. Yes, I'm glad most people have their past question. Yes, seen a lot of students bringing it out. It means you have it. That's good. Well done. Make sure you're studying it. I saw someone's past question yesterday. Still very new. I see she just bought it. Bad. That's bad. Make sure you're studying. If you're not studying, give it to someone that will study it. Please give it to someone that will do what? Study it. Please, someone look for that question in your person where they asked for inertia. The answer was inertia. Please, someone look for it for me and notify me quickly. If you have seen it, let me know. I don't have that time. Have you seen it? Page 57, number 14. Page 57. Let me see there. Page 57, number 14. Yes. So the tendency of an object to resist a change in its state. The tendency of an object to what? To resist a change of its state, either at rest. You see, there are two components of the inertia. Either at or motion at constant speed. So uniform motion means motion at constant speed. Speed means velocity, right? Just simple, a tendency of an object to resist a change in its state, either at rest or what? At constant speed along a straight line is called dash. A, momentum. B, dynamics. C, inertia. D, friction. The answer is inertia. The answer is inertia. Tendency of a body to what? To resist a change of its state, either at rest or motion at constant speed. The answer is what? Inertia. The answer is inertia. So, class, you see that as simple as this is, you are being asked in the exam. Moving forward, class, I haven't stated the law and explained what the law means. It's now trying to take the mathematical implication of the law, class. So what this first law of motion means is that force is directly proportional to acceleration. That means for there to be acceleration of a body, there must be force is required. Force is what? Required. And class, if force is required, the constant will come in to bring this proportionality sign, and we have F equals to ma. So mathematically, what Newton's first law of motion is telling us is that the applied force on a body is directly proportional to the acceleration produced by the body. So it means the higher the force, the higher the acceleration. More force equals more acceleration. Less force means less acceleration. And the constant that comes in is the mass. F equals to ma. Now, class, this force is the net force, actually. It's what we call net force. You know, in secondary school, you are not really specifically taught this. You just know that F equals to ma. But class, there are some questions they will give you in physics university level that will challenge your understanding of F equals to ma. Because class, from secondary school, you just know that if they give you mass and A, just say M times A, F, you get your force. But class, in the university, you could be given a question that already contains force, and yet you are still asked to find force. You could be given a question that already contains what? Force, and yet being asked to find force. Let's take our first question. Let's take our first, so you can see what we are talking about. A car of mass 500 kg. A car of mass 500 kg. A car of mass 500 kg. Moving with forward acceleration of 6 meters per second square. Moving with forward acceleration of 6 meters per second square. A car of mass 500 kg. Moving with forward acceleration of 6 meters per second square. Is acted upon by a constant resistive force. Is acted upon by a constant resistive force. Is acted upon by a constant resistive force. Is acted upon by a constant resistive force of 800 Newton. The question said a car of mass 500 kg moving with a forward acceleration of 6 meters per second square is acted upon by a constant resistive force of 800 Newton. Class, force of what? So in your mind, they are giving you force. They cannot ask to find force again. Calculate the force. Calculate the... but this is force now. Calculate the force. So there are different types of force, class. Exerted. Calculate the force exerted from the engine to maintain this forward acceleration. Calculate the force exerted from the engine to maintain this forward acceleration. Calculate the force exerted from the engine to maintain this forward acceleration. A car of mass 500 kg, acceleration in centimeter per second square, is acted upon by a force, constant resistive force, 800 Newton. Calculate the force. Class, someone that just knows force as mass and acceleration without understanding the details, we think that this mass now, M is 500 kg, right? Acceleration is 6, right? So 500 times 6 should give me my force, right? 500 times 6 should give me 3,000 Newton. And in your option, I can bet you see 3,000, but you're wrong. Because someone just crammed force as mass and acceleration without understanding the details involved. Yes, this mass, this acceleration. Nothing concerns me with this job. 500 times 6, 3,000, but you're wrong. I must explain something to you, class. That is a concept known as net force. There's a concept known as what? Class, it is possible for two forces to be acting on a body, F1 and F2. Class, one force is acting in this direction, the other force acting in this. And class, the body will move towards the direction of the bigger force. The body will move towards the direction of the what? If this F1 is 200 Newton and F2 is 500 Newton, be rest assured that this body will move in this direction. But class, for there to be acceleration in this direction, this 500 Newton must overcome this 200 so that a net force is produced. A net force is what? The net force is the bigger force, F2, minus the smaller force, F, which is 500 minus 2. Right, it's the 500 minus 200 that is equal to mass times acceleration. It's equal to what? It is the net force that is equal to MA. So class, imagine they give you a force, a body is acted upon by two forces, 500 Newton and 200 Newton. And the mass of the body is 10 kg. And they say find the acceleration produced by the body. They say find the acceleration produced by the what? And class, you know that force equals to mass times acceleration, right? They say find the acceleration. Mass is 10 kg. Mass is 10 kg. You don't know the acceleration. Someone that is not taught well will be thinking, which of these forces will I use? You will now use only 500 equals to 10A. Because F equals to M. And you're looking for A, right? Let's leave this one question. I want you to understand something here. F, 500 equals to M, 10. A is A you're looking for. You divide both sides by 10, right? To make A squared on the formula. 500 divided by 10, you have 50. And you think you are right, but you are wrong. Or you go and use the second force, 200 equals to MA. You are still wrong. Class, any of these forces you use on their own, you are, class, you have to resolve the forces. There's what we call resolution of force to get the net force. The correct force you are supposed to use is the net. And the net force is the bigger force, 500, minus smaller force, 2, equals to mass, 10. Then you now look for the acceleration. 500 minus 200 is 300 equals to 10A. Funny enough, if you use 500 only, you see your answer in the option. If you use 200 only, you see your answer in the option. But it's the relation of 500 and 200 that gives you 300. Divide both side by 10. Divide both side by what? So that A is 300 over 10. That gives you 30 meters per second. Class, that's the acceleration produced by this body. Now, class, this is the first case scenario when the forces are acting opposite to each other. Class, doesn't mean that anytime you see two forces, you must subtract bigger minus lesser force. It depends on the condition of the two forces. We are subtracting here because these two forces are acting opposite direction to each. Class, another question could be given where the two forces are acting in the same direction. You will not subtract. Those forces are said to be complementary. Are said to be what? When the two forces are complementary, class, instead of subtracting, you add them. You do what? Class, two forces F1 and F2 acting in the same direction. F1 is, let's say the same force, 200 Newton. And what was F2? 5. Now, someone that's cranked A, anytime you see two forces, just subtract, will now be wrong again. So the rule keeps changing depending on the conditions. And it's not good to cram one thing when studying or understanding a concept. Class, because these two forces are acting in the same direction, we don't subtract, we add them because they are all working for the same purpose, right? F1 plus F2 equals to MA. So the net force here is addition. But in the former question, the net force was subtract because they are acting in opposite direction. But now they're acting in the same direction, add them up. So F200 plus 500 equals to mass 10. Then you look for the acceleration. 200 plus 500 is 7 equals to 10A. 700 equals to 10A. Divide both side by 10. So that 700 divided by 10 is 70 meter per second. So class, how the two forces are acting on the body matters. How the two forces are acting on the body before you solve. Let's now go back to our original question. I'll give you a full minute to write, and let's go back to our original question. Class, moving forward to our original question now. A car of mass 500 kg. So mass of the car is 500. Moving with a forward acceleration. Acceleration is 6 meters per second. Is acted upon by a constant resistance. So let this be the car. Is acted upon by a constant resistive force. Resistive force is always acting in opposite direction to the main force. So resistive force of 800 Newton class. Be rest assured that this is not the main force. That's why they are saying RCA to find the force. This is not the main force. This is acted upon by a constant resistive force. This is the opposing force. The main force will be on this other. Is acted upon by a constant resistive. This one is resisting. It doesn't want the body to move. But they say calculate the force exerted from the engine. The engine wants to move like this, but the resistive force opposing it. Calculate this bigger force that will make the engine to have a forward, maintain the forward acceleration. To maintain this forward. So class, it means that this bigger force minus this smaller force, 800, must be equal to mass times. Class, they did not need to say that the forces act in opposite direction. By using the word resistive, it means that one is opposing the other. Can one force be resistive and they be acting in the same direction? No. It's clearly that resistive force is acting opposite to what the normal force is. So it is this normal force they are asking you to find. So this is a case where you can be given force and still have to find force. So it's your understanding of physics that will matter here. So it's this F we are looking for. So F minus 800 equals to M. Mass of the body is 500 kg. And acceleration is 6 meters per second. F minus 800 equals to 500 times 6. 3,000. Making F squared to the formula, we have 3,000 plus 8. 3,000 plus 800 gives 3,800 Newton. This is the force that must be acted on this engine to maintain the forward acceleration. This is the force that must be acted to maintain the forward acceleration. A body of mass 4 kg undergoes a constant horizontal acceleration of 3 meters per second square. Calculate the resultant horizontal force acting on the body. Calculate the resultant horizontal force acting on the body. Class, another name for net force is horizontal force. Another name for net force is horizontal force. Calculate the resultant horizontal force acting on the body. So I chose this class. I knew that this class, at least, there's less heat and there's possibility of, if they bring lights fan. See, 4 fans. There's no way anybody can be feeling hot here with these 4 fans. In PSO, you don't have that possibility. Thank God, some people now, because of the online class, they have become lazy now. So I don't need a very big hall again. So anybody that is coming to class, I will teach. You don't come, you won't say that you paid me, I did not teach Abi. There's no day I've missed my class. Me, I'll come every day till the end of the semester. Even if it's one semester I see, I'll teach. So to now be up to the students. You won't say you paid and they did not teach. That's you never hear that about me. I'll teach my class. I will not miss one day till the semester will end. Said it. I don't joke. I'm very highly super consistent. I don't joke with my classes. Class. What will be the resultant force on the body? Class. Continuation of the question. What will be the resultant force on the body when it moves with a uniform velocity of 6 meters per second, of 6 meters per, when it moves with a uniform velocity of 6 meters per seconds, it's still a part of the question. When it moves the uniform velocity of 6 meters per seconds. Now, class, a body of mass 4 kg, mass is 4 kg. A body of mass 4 what? Kg. Undergoes a constant horizontal acceleration. Acceleration A is 3 meters per second square. Calculate the resultant force acting on the body. Class, the resultant force means the net is mass times acceleration, class. We clearly have mass as 4 and acceleration as 3. Class, the first part of the question is very simple. Answer is 12 Newton. Our answer is 12. But the second part now says calculate the resultant force. Okay, what will be the resultant force? Second part on the body when it moves to uniform velocity of 6 meters per second. Class, note that at uniform velocity, acceleration is 0. The second part of the question is saying find the resultant force if it moves to a uniform velocity. At uniform velocity means that there is no change in velocity, right? That means initial and final are the same. And if there is no change in velocity, acceleration is usually changing velocity all over time, right? If the two velocities are the same, if this is 5, this is also 5. So whatever the time is, 5 minus 5, 0. 0 all over t, 0. Class, if there is no change in velocity, the consequence will be that the acceleration will be what? At uniform velocity, acceleration A is what? And class, if acceleration A is 0, force is mass times acceleration, right? It means my force is also 0. Mass times 0 is what? So class, anytime they give you to find a resultant force on a body acting at constant velocity or uniform velocity, class, they're just giving you a bonus question. If you know what you're doing, your answer is what? 0. At uniform velocity, though, so someone will now say, Sabo, you know you do 6 for anything. Yes. It's not every question they give you, every parameter they give you in a question that you must use, class. Some parameters they give you in a question are distractors. They are what? They are to distract you. Class, this is just for information's sake that the body is moving with a uniform velocity of 6 meters per second. That's its uniform velocity. That means this velocity never changed. It continued at that 6. Uniform velocity of 6 means that there was no time when it changed from 6. Constantly 6 till the end. And if the velocity remains the same till the end, it means the acceleration is what? 0. Because it means that, okay, let's even actually use it. That velocity, initial, final velocity is 6, or V means final velocity. Initial velocity is also 6 minus 6, 0. Whatever the time is, 0 over time, 0. Because acceleration is changing velocity per unit time, right? Acceleration is changing velocity per unit time, increase in velocity per unit. But if there's no increase in velocity, it means acceleration is 0. What will cause for there to be no increase in velocity? If there is moving at uniform velocity, there is no increase or change in velocity. Therefore, acceleration is 0. And if acceleration is 0, my force is also, because force is mass times acceleration. So mass times 0 gives me, so don't need to solve in the exam. Just look for 0 and enjoy yourself. If you don't see 0, look for none of the above. Look for what? None of the above. Now moving forward. An object of mass 4 kg an object of mass 4 kg is acted upon by two horizontal forces. Is acted upon by two horizontal forces. 8 Newton and 2 Newton in opposite direction. 8 Newton and 2 Newton in opposite direction. 8 Newton and 2 Newton in opposite directions. 8 Newton and 2 Newton in opposite directions. Let it drop. If you put it and not drop now, it will still finish on time. 8 Newton and 2 Newton in opposite direction. Calculate the acceleration produced by the system. Calculate the acceleration produced by the system. Calculate the acceleration produced by the system. Calculate the acceleration produced by the what? System. Class, I believe you can solve this. An object of mass 4 kg. Mass is 4. Acted upon by two forces. 8 and 2 Newton, right? In opposite. Calculate the acceleration. What will you do? 8 minus equals to mass times acceleration. Mass is 4 kg. We're looking for the acceleration. 8 minus 2 is what? 6. 6 equals to 4. Divide both sides by 4. 6 over 4 is 1.5 meter per second. 1.5 meter per second square. 1.5 meter per second square. A body of mass 2 kg. Okay, a body has a mass, not of mass. A body has a mass 2 kg. Calculate the force acting on this body to produce a velocity of 3.6 meter per second in a time of 12 seconds. In a time of 12 seconds. A body has a mass 2 kg. Calculate the force acting on this body to produce a velocity of 3.6 meter per second in a time of 12 seconds. In a time of what? 12 seconds. In a time of 12 seconds. A body has a mass of what? 2 kg. Calculate the force. We don't know the force. Produce a velocity of 3.6 meter per in a time of 12. Time is 12 seconds. Class, we should also know that if force is mass times acceleration, acceleration is velocity all over. So that force can also be equal to mass times velocity all over time, which is mass 2, velocity 3.6 time 12. 2 times 3.6 divided by 12 will land you on 0.6 Newton. If you resolve everything, you should have 0.6 Newton. So is this correct? Okay, it's correct. Okay. Let's now go to second law of motion. All these questions were taken under first law. Don't forget we are under dynamics. And in dynamics, study of motion with reference to what? The causative forces of motion. And class, to further explain dynamics, we have 3 laws of motion. Newton's laws of motion helps us understand how these forces causes motion. So we have the first law, we have the second law, and we have the third law. So now we've just looked at the first law and taken several examples. Let's go to the second law. Second law of motion states that, using second law of motion, class, say second law is called law of momentum. Newton's second law of motion states that the rate of change of linear momentum is directly proportional to the applied force and takes place in the direction in which the force acts. And takes place in the direction in which the force acts. Newton's second law of motion states that the rate of change of linear momentum is directly proportional to the applied force and takes place in the direction in which the force acts. Class, according to the second law of motion, the mathematical implication is that the rate of change of linear momentum, class, what we call linear momentum. Momentum is speed. The symbol for momentum is what? And naturally, momentum is mass times velocity. But we have 2 types of velocity. We have initial velocity, and momentum can also be equal to mass times final. When momentum is mass times initial velocity, it's called initial momentum. Mass times final velocity is called final momentum. We use I for initial. Pi, initial momentum. P is symbol for momentum. Why do we call it linear momentum? Because we also have what we call angular momentum. We have what we call what? So this linear momentum is momentum of a body undergoing linear motion. Angular momentum is momentum of a body undergoing circular motion. Linear momentum is momentum of a body undergoing linear. Angular momentum is momentum of a body undergoing circular motion. So we have two types of momentum. When we get to rotational dynamics, we will study angular momentum under rotational dynamics. Under rotational what? Class. The question says the rate of change in momentum, therefore, delta P means changing is final momentum minus initial. Change in momentum is final momentum minus what? So if they say the rate of change of, and that is final is what? mv. Initial is m. So class, the change in momentum of a body is mv minus mu. The change in momentum of a body is what? mv minus m. And we are told that the rate of change, rate means time. So the rate of change of momentum means rate of change of momentum all over time. That is, rate of change of linear momentum is momentum, change of momentum all over is equal to the force. It means that force F equals to change in momentum all over time. And change in momentum is what? mv minus m. If you bring out, factorize m here, we're going to have m into bracket v minus all over what? Time. So class, from Newton's second law of motion, we're able to derive that the force acting on the body is m into bracket v minus u all over t time. M into bracket v minus u all over t time. Class, further deductions from this can lead us somewhere else. So if we have established that F equals to M into bracket V minus U all over T, a simple cross multiplication of this will give us F times T, Ft equals to M into bracket V minus U. And we all know that F times T is impulse. Force times time is what? So we can say impulse now equals to M into bracket V minus U. Impulse now equals to M into bracket V minus U. And what this means is that class, sometimes a student might know that the formula for impulse is just force times time, and you don't know any other formula for impulse. I'm here to show you now that impulse can also be obtained by multiplying the mass, final velocity minus initial velocity. Let's take our first question for the day. A body of mass 6 kg, a body of mass 6 kg, a body of mass 6 kg, moving with a speed of 20 meters per second. A body of mass 6 kg, a body of mass 6 kg, moving with a speed of 20 meters per second. A body of mass what? 6 kg, moving with a speed of 20 meters per second. Initial speed is 20 meters per second. It suddenly hits by another body moving in the same direction. It suddenly hits by another body moving in the same direction. It suddenly hits by another body moving in the same direction, thereby changing the speed of the former body to 50 meters per second. Thereby changing the speed of the former body to 50 meters per thereby changing the speed of the former body to 50 meters per second. Thereby changing the speed of the former body to 50 meters per second. What is the impulse received by the first body? What is the impulse received by the first body? What is the impulse received by the first body? I'll come again. I say a body of mass 6 kg, moving with a speed of 20 meters per second. So initial speed is 20 meters per second. is suddenly hit by another body moving the same direction, thereby changing the speed of the former body to 50 meters per seconds. What is the impulse received by the first body? Class, the impulse I, which I've just shown you, you see that a student that knows impulse as just force times time will be struggling here because there's no force and time here. But now with this second law of motion, that's allowed us to understand that impulse is mass into bracket V minus, and my mass is 6, my V is 50, my U is 6, 50 minus 20 is 30, 6 times 30 is 180 kilogram meter per 180 kilogram meter per seconds. Class, moving forward, another question. An 8 kg block is at rest at t equals 0. An 8 kg block is at rest at t equals 0. A constant force F acts on the block. A constant force F acts on the block along the x-axis at t equals 2 seconds. The block moved at t equals 2 seconds. The block has moved 4 meters. Has moved 4 at t equals 2 seconds. The block has moved 4 meters. Find F. Find at t equals 2 seconds. The block has moved 4 meters. Find F. Find what? F. At t equals 2 seconds, the block has moved 4 meters. Find F. An 8 kg block is at rest at t equals 0. At rest means u is 0 meter per initial speed of the, or initial velocity is 0 meter per seconds. Mass is 8 kg. Obviously, you can see there an 8 kg block. Constant force F acts on the block. We don't know the force. That's what we're looking for, right? Now, at t equals 2 seconds. The block has covered the distance, has moved 4 meters. S is 4. We're asked to find F. Class, we know that force is mass times acceleration. We have mass 8 kg. We don't have acceleration. But class, we can get acceleration. We must remember our equation of motion to get acceleration. V equals to u plus at. Do we have V? No. So this equation cannot work. What are we looking for? We're looking for acceleration. They gave us distance covered. They gave us time. They gave us initial velocity. They did not give us acceleration. If they gave us u and they gave us v, class, I would have just said F equals to m into bracket v minus u, right? I'll use this equation, right? Since I have time is 2 seconds. I have u, but they didn't give me v. So I cannot use this formula. I cannot use this. I need to go and get, except I will get v, except I will get what? If I'm to get v, I don't have a. So I cannot even get v from this equation. Do I have a? No. So class, if you look at, this is the equation of motion, S equals to ut plus half at squared to get a. To get what? We're going to use S equals to ut plus half at squared. Plus my S is 4. My u is 0. My t is 2 seconds, right? Plus half a. T is 2 seconds. That's 2 square. Class 4 equals to 0 times 2 is 0. Plus class 2 cancels 1, 2 here. Leaving only 1, 2 here. So 2 times a. 2a. So 2a equals to 4. If you make a set of the formula, we have 4 divided by, if 2a equals to 4, this 0 will go now. Make a set of formula, divide both sides by 2, so that a is 4 divided by 2, which is 2 meter per second. Class, we have to go, this question required us to use the equation of motion to get a first. Having gotten A as 2 meters per second square, we can then proceed to get the force. Our force is mass, 8 kg times 2. 8 times 2, 16 Newton. 16 what? So we first had to go and get our acceleration using equation of motion. So this question links kinematics to dynamics. Because going back to equation of motion is kinematics. Getting a value from there to come and solve for the force is dynamics. While you're writing the solution, another question will... Class, this next question I want to give you is a question that links dynamics to vectors. If you attended this dynamics class before, I have not given this example, but I want to give it now. And it's actually a bit more complicated, but let's look at it. A particle of mass, this one links dynamics to vectors. A particle of mass, 0.4 kg, is subjected to two forces. Subjected to what? Is subjected to two forces. F1 equals 2I minus 4j, and F2 equals minus 2.6I plus 5j. If the particle starts from rest, if the particle starts from rest at the origin, find its position and velocity at t equals 1.6 seconds. At t equals 1.6 seconds. Find its position and velocity at t equals 1.6 seconds. At t equals what? 1.6 seconds. Class, a particle of mass 0.4 kg is subjected to two forces. Class, did they say the forces are acting in opposite direction? No. I gave you this question intentionally because if the question does not say opposite direction, do not assume. Class, assume the positive, meaning that they're acting in the same direction. It's related to two forces. F1. Class, if it's opposite direction, it will be mentioned clearly. 2I minus 4j. And F2 minus 2.6I plus 5j. Class, what did I tell you about two forces acting in the same direction? What will be the net force? Add them up, right? Class, adding these two forces, what topic does it fall under? These are not two vectors. Addition of vectors, right? This is under addition of... So someone must have learned vectors so you can even attend this question because you have to add up these two forces. And class, is it wrong to represent force in vector form? It's not wrong because force is actually a vector quantity, right? So it can be expressed in the form I and J component. Class, F1 means that the force acted 2 Newton in the x-axis and 4 Newton in the negative y. Follow me. I can show this force, represent this force in a graph. It means that this force was acting 2 Newton on the x-axis. I represent the x-axis, do you remember? And 4 Newton on the negative y-axis. J represents the y. But this minus means on the negative y-axis. Class, from the origin to the down is negative y. From the origin up is positive. So minus means that it came down. But plus 2 means that from the origin to the right is positive x-axis. From the origin to the left, negative x. So this body covered 2 Newton on the x-axis and on the positive x-axis and 4 Newton on the negative y. This is the relation of these forces. This positive x-axis, yes. Positive x to the right. This negative x. This negative. So if we are to actually have it, that's correct. If we are to have it, I think we should have something like this. Positive, if this is our origin, we have, it came down. Okay, we should have this. So we have 2 Newton and 4 Newton. We don't need to say minus. This down has already shown the what? Negative y-axis. Coming down has shown the minus. This is a graph. So by looking at the coming down, say this is negative y. This is positive x. We're representing the graph. If you now find the resolution of this, it's now the magnitude of the vector with that direction. For class, we've already done vectors yesterday, but I was just trying to remind you. Now, what we have to do here is that these two forces, I've just explained to you that these two forces can be broken down and shown what it means. 2i minus 4j, I just showed you what it means. Minus 2.6i means I covered minus 2.6 on the negative x and then covered what? Positive y plus 5 on the positive y axis. Now, class, we want to find the net force. The net force of between two forces acting in the same direction. They are complementary. I'm going to add them up. So 2i minus 2.6i. Class, we're adding them up, but because of this minus, it's making us minus, you understand? But it's actually addition. Because plus times minus gives us what? Minus. When there's a minus, even if you're adding, the minus supersedes the plus. You know that. So 2 minus 2.6 minus 0.6i. Now, minus 4 plus 5. Minus 4 plus 5 is plus 1j. You can use your calculator. You can use your calculator. Close to the net force between these two forces acting on the body is minus 0.6i plus 1j. Minus 0.6i plus 1j. Class, don't forget that net force is one that is equal to mass times acceleration. So who is my net force? Minus 0.6i plus 1j is my net. Equals to what's my mass? 8 kg. My mass of the body is what? A particle of mass. Oh, 0.4, sorry. A particle of mass, 0. Do I have acceleration? No. Class, is it acceleration they asked me to find? No. Find it. Position means displacement. Anytime I say find position, it means displace and velocity at t equals 1.6. So we need the position and velocity. We need the position and what? To get the position and velocity, we must first find the acceleration. We must first find the what? Net force is adding these two forces because they act in the same direction. How do you know they act in the same direction? A particle of mass 0.4 kg is subjected to two forces. And the statement stopped here. Class, if they were in opposite direction, it will not stop here. They will have said in opposite direction, or one is resistive. So class, since they are in the same direction, we add them to get the net. I haven't gotten the net force as this. We're now going to find net force equal to mass times acceleration. Make acceleration so the formula, divide both sides by 0. Class, we're going to obviously get our acceleration in vector component, I and j component. And it's not wrong because acceleration is also a vector quantity. Acceleration is also a what? So class, acceleration is minus 0.6 I over 4 plus 1j over 4. Because this over 0.4 over 0. Because this 0.4 under belongs to both this and so we split them. We split so that A equals to, someone should help me. What is minus 0.6 divided by 0.4? Minus 0.6 divided by 0.4. Eh? Minus 0.15. Class, is 0.15 or 1.5? Eh? Minus 1.5i plus what is 1 divided by 0.4? Looks like 2.5. Check. 1 divided by 0.4 is 2.5 j. I'm not using calculator, but I know when they divide something, I know what it should give, possible thing it should give. You can know that 0.6 is bigger than 0.4, so we shouldn't have a 0 point as an answer. When you told me 0.15, I was already skeptical. This is bigger than this. When numerator is bigger than denominator, your final answer should be greater than 1 at least. When numerator is bigger than denominator, so when you say 0 point, still less than 1, and this is bigger than this, something is wrong somewhere. Class, this is our acceleration. Class, acceleration is minus 1.5i plus 2.5j. This acceleration means that the body covers 1.5 meter per second square on the x-axis. Sorry, minus 1.5 meter per second square on the x-axis. And it covers 2.5 meter per second square on the y. So class, if you say acceleration is minus 1.5i plus 2.5j, it means the acceleration on the x-axis, ax, is minus 1 point. And acceleration on the y-axis, ay, is 2 point. You see why you must have been taught vector before coming here. So minus 1.5 meter per second square is on the x-axis and 2.5 meter per second square on the y. Because what makes me say minus 1.5 is x? Because I represents x, I represents what? And j represents y. Thank God we just did vector yesterday. Do your best to be following up on the video. If you're missing class, be following up on the videos I'm posting. Class, we're not done. That's not even the main question. The main question says we should find the position and velocity at t equals 1.6 seconds. Class, I want to clean just this side. Class, so as it stands now, I need to get the position and the velocity at 1.6 seconds. But class, did they tell us that if the particle starts on red, the particle starts on what? If the particle starts on what? So it means that u initial velocity is 0 meter per. If the particle starts on rest, initial velocity is what? 0. Find its position and velocity at t equals 1.6 seconds. Now let's just find the velocity. Velocity is u plus at. For class, we're going to find the velocity in 2 dimensions on the x-axis and on the y. Because velocity is also a vector quantity, so it can exist in 2 dimensions. The velocity on the x-axis will be u plus axt. We're going to use acceleration on the x-axis to get velocity on the x. And velocity on the y-axis will be u plus ayt. We use acceleration on the y. What's now velocity on the x-axis? Velocity on the x-axis will be u is 0, right? Plus, what's ax? Minus 1.5. What's time? T, 1.6. T is what? 1.6 seconds. So we'll say times 1.6. Vx, this 0 has gone now. Minus 1.5 times 1.6. Someone should help us. Minus 2.4. Minus 2.4 meter per second. So like this is the velocity of the body on the x. Let's go and get velocity of the body on the y-axis. U is what? 0 plus ay. 2.5. Time is 1.6 at t equals 1.6 seconds. Don't forget. What is 2.5 times 1.6? 4 meter per velocity on the y-axis. Class, with this information, I believe we should have been done with this side now. Class, with this information, I can now represent the velocity, total velocity of this body. What is the one on the x-axis? Minus 2.4i, because x represents the I, right? Plus 4j, plus 4. If I want to write it back to in vector, because the question started with in vector form, right? Meter per second. This is the velocity of this body in vector form. Minus 2.4i plus 4j. Some students only like simple questions. Once it's hard like this, I don't not simple things. You will not improve. If they are only giving you FMA, everybody will be happy. You need tough questions to get better, to get good. So they start with simple questions to make you like the topic. We then go to the tough to build your confidence. Nobody starts the topic with hard question immediately. Start with simple question, then you go to the hard one.